and Informatics. I'm part of the AI lab, which means the artificial intelligence lab in our faculty, and which was established, and we are dealing with some interesting problems and interesting, let's say, research tasks regarding to some smart solutions for some optimization problems and so on. So just briefly the outline of this short talk, I would like to introduce very briefly and fastly some background for the AI-based the techniques and methods which will be introduced in this talk. Something about the symbolic regression tools, and then I will just skip to the main part, which is the concept of analytic programming, which I would like to introduce a little bit more with some deeper insights and some examples for the end. So, first important thing, the artificial intelligence. There are a lot of techniques or a lot of techniques and methods which belongs to the artificial intelligence paradigm, besides the intelligent machines, robotics, and so on. So there is also the neural networks, evolutionary algorithms, and symbolic regression, which is the part of this AI paradigm. So I would like to talk about this part. And regarding to artificial intelligence, it's a very powerful tool, and the only key is that we have to know what we want to achieve. If you look at these pictures, the left one, do you see 4 circles, like from Pac-Man? Or do you see something like invisible rectangle? It's based on you. And on the right picture, what do you see? Can you find something? Yes. There's a cowboy riding a horse. If you look at this is a horse, this is a cowboy. Yeah. And now you will try how the artificial intelligence works. If I show you this picture to you 5 years later, 20 years later, you will always know that there's a cowboy who is riding the horse. Your brain will memorize it. So the artificial intelligence is a very powerful tool. The only problem is that we have to know, we really have to know what we want to achieve, how and exactly. So I will make just a little brief introduction into evolution computation, evolution algorithms field. So the evolution algorithms belongs to soft computer AI field. It's a nice tool for optimization of hard problems. The terminology was basically taken from the nature, so we were inspired in the natural processes, and we can work with some integer, real, or mixed variables. Is not a problem. The thing is that there's some requirement for some mathematical model of the problems we want to optimize. We want to find a solution, which is sometimes called cost function or objective function or fitness function. Depends on the algorithm and implementation. Basically, the aim is to find the global extreme of such a function. This function could, for example, could look like this. Every red dot is one solution. So the evolution algorithms are based on very easy and smart idea that if we have a population, so we have several solutions spread on this cost function surface, which is describing the quality of the solution, and then we just perform any process which was inspired from nature, so we can cross over this solution, we can make some mutation, or we can somehow can be inspired in the natural swarm of the bees and cuckoos and some bird and the fish, so we can let these particle solutions fly over this cost function surface, and we will try to find the best solution in some iterative way. So this is the evolutionary algorithms. And for example, these cost functions can look like this. Sometimes it can be very peaceful, like this left upper part, or sometimes it's very crazy, so we need sometimes very powerful intelligent technique to solve the problem. Why is it evolutionary? Because we were inspired in the natural evolution process. So basically we generate some first solution, and then we select like a parents, some good candidate solutions, make some crossover combination between the parameters, make some mutation. Again, then we have basically two populations. So there's the parents, there's the offsprings, and now we select again the best ones, which will continue to another round, another iteration. With this, we can solve very difficult problems in a very short time with some, let's say, reasonable amount of computational demands. And basically, these are some examples of the evolution algorithms or swarm techniques which are used commonly now. The genetic algorithms, which are such a standard from 1975. Differential evolution is one of the most potent heuristic now, the winner of many competitions. Then we have, for example, the SOMA, which was developed in my department, particle swarm, and colony optimization, which are very famous for solving some, let's say, the problems regarding to finding shortest path in the network and so on, scatter search, and many other the algorithms which are mostly inspired by the natural swarm processes. As I already mentioned, there can be artificial bee colony, the cuckoo search, gray wolf algorithm, and many more. I think that there are 250 algorithms already which are inspired by swarm processes or let's say swarm intelligence from the nature. But let's say the evolution algorithms are very capable in the problem solving. Like we've got some model, we've got the cost function, and we need to sort out, we need to find the best combination of the parameters for this model. So in this case, we are working with already given model, and we are trying to fit the best combination of the parameters, to tune the parameters, so that the system will behave as we wish, as it is optimal, and so on. But the symbolic regression is going a little bit one step higher. So why not use the evolutionary process to evolve this model, including the, let's say, the best combination of the parameters? So we are not using the evolution algorithms, let's say, just only for the finding of optimal combinations of the parameters for some given model, but we can use the evolutionary processes, evolution algorithms for synthesis, for let's say evolving of the whole new model, let's say complex structures, formulas, whatever, depends on the field where we need it, and together with the optimal values of these parameters. So this is the symbolic regression. Basically, we take the bricks, from the bricks we build the house. This is some basic formulas, basic part of the models, and from this house we build a city. And we tune the city, we just reshape the city so it will work as we wish. So this is the symbolic regression. This is like a brief overview. So as I already said, that it's a process of, let's say, complex structure synthesis, and we can synthesize the formula which will fit the measured data. We can synthesize some control program, control process. We can synthesize the workflow, for example, for decision-making process. We can synthesize the workflow, how the company will behave. The last example which we have done, for example, in our faculty is that we have synthesized, for example, the PetriNet workflow, how the mobile 3G and 4G network will behave in case of, let's say, when too many users are downloading some data from BTS stations and so on. So you can synthesize, let's say, many applications or many models and formulas or complex structure for, let's say, almost infinite number of applications. So something is wrong. It's too far. Okay. So as I already said, we can, for example, synthesize, and this was already done, the shape of the antenna for some interstellar mission. For NASA, we can synthesize the best path for some autonomous robot or AUV and so on. And basically, these are the selected methods which you can use. Firstly is the genetic programming. It's natural, because the genetic algorithms are the oldest one, standardized, and the genetic programming was a tool for, let's say, reuse these genetic algorithms to synthesize the programs, synthesize the code, formulas, and so on. But the problem is that that time, when it was introduced, you have to work with the Lisp program, you have to work with the trees. Basically, it's like a crossover and combination of the trees of the code and the programs. And of course, you are limited to use the genetic programming, which is natural because you are working with genetic programming, so we have to use the genetic algorithms. are using this general function set, which is our, let's say, the building material for the formulas and complex structures, and together with the discrete set handling, which is transferring the, let's say, information from evolutionary system or from some intelligent technique which is evolving some good solution on the background, we can link this, let's say, nice solution to this general function set. So it will be explained here. So this general function set, we are using terminals, not terminals, functions, but it can be anything what you need to synthesize. So, for example, here we let's say we are using so-called general function set, 0 arguments, general function set, 1 argument, GFS, 2 arguments, which means that also we have to classify these elements, these building elements, to the functions which has, for example, 0 arguments, which are terminals, constants, concrete value, particle values, and many other, or some numerical values for the constants. Then we have a GFS with 1 argument, which is, for example, the function sinus, cosinus, and so on. And then we have a general function set with 2 arguments, which are usually operators like plus, minus, and so on, because we need something plus something. You always need 2 arguments for this operator. So firstly we have to do the classification of these functions, which we basically use as a key elements for the synthesis of formula, to GFS 0, GFS 1, 2, of course, then we create the GFS all. And then we have a discrete set handling, which is easy trick, because what was already shown on some slides regarding to evolution algorithms. The evolution algorithms are capable of giving us some numerical solutions, some numerical set of parameters, and which is basically the parameter of the solved problem. Here we are using these numerical parameters as like a link or like a mapping for this general function set. So we are let the evolutionary algorithms to give us some set of integers like 1, 3, 7, 5, something, and then we take these numbers and link it to the general function set and create the formula. If the formula is good, this solution is good and can be used for the evolutionary process. If this formula is not good, it is erased, deleted. So of course this solution, these integer numbers, are omitted. So this is the discrete set handling. Then we have security procedures. For example, here is example. The security procedures are very important in case of the genetic programming or whatever techniques from simple regression, because we are synthesizing the programs, the formulas. And we are doing it with some artificial intelligence on the background. But this artificial intelligence is just used for linkage between, let's say, the space of the, let's say, the evolutionary process and space of the process of the functions, terminals and non-terminals. So it can, for example, give us the solution, I don't know, 5, 5, 5, 5, 5, which is linked to the general function set where it's function sinus or cosinus, which will give us the cosinus of the cosinus of the cosinus of the cosinus of the cosinus and nothing more. But where is the argument? Where is some terminal? Where is some function? Where is some value? So it is missing. So this is like a pathological program, so it must be deleted from the population. So this is security procedures, and the last thing is a constants, which is basically the biggest problem if you want to use these techniques for simple regression, because it's not a problem to define the operators, the functions, which you need in your formula or in your complex system which is being synthesized. But what about the constants? Is it 2.37 good value or is it 1.55 good value? Who knows? You never know, because you want to synthesize the model together with some numerical values and the constants which will fit the data or which will fit your needs. So the defining of the constants and or trying to find them is the biggest issue now, and we are still working on the development techniques. So here is some example, maybe. Okay. So for example, this is example of discrete set handling. We've got the individual. So the evolutionary algorithm will give us such an individual, 0.12, 4.29, and so on. Then we have to do some roundings. So we have to round it because we cannot link 4.29 to some position in some discrete set. So we run the individual to 0, 4, 7, 6, 2, and so on. And then we look into general function set all. And if you look at here, you can see that it's like 0, 1, 2, 3, 4. So it takes a 0. The first one is plus. So it gives us the plus. And then the DSH knows that we need 2 or more operators. 4 and 7 is linked to sinus and some constant. So we have a sinus and constant. This is a terminal, this is closed. And what about this? The evolutionary algorithm knows, or this DSH knows, that okay, we need something more. 6 is this. And the formula is closed, and this one, for example, the rest of the individual is not needed anymore. So basically this is this discrete set handling, so the linkage or mapping between the individual which is given from piezo, DE or whatever, the evolutionary technique which is only, the evolutionary technique is on the background and it drives the analytical programming and only gives the let's say integer set or let's say real value set which we round, and we can link this to some general function set. Here is a little bit more detailed, some example. So, for example, we have a little bit different function set. Here's plus, minus, and so on. And for example, we have implemented it in MATLAB or some different language, where, for example, the fields are, or the arrays are not starting with 0 but with 1. This is, for example, the case of Wolfram Mathematica and other software. And now you look at it that the first individual is again plus. So we need argument plus argument. So we take another 2 position from the individual, 6 and 7, which is sinus and cosinus. Again, we need another arguments. So we look into the individual, it's 8 and 9. And in 8 and 9, so we can find, for example, the functions tangent and finally some variable t. And we need another argument. But the thing is that we have the last available position in the individual. So we have to be very careful about this. And here, for example, there was 11, but 11 is pointing to, for example, the function module, mod. But function mod is needs 2 arguments. We need what is divided by what. So, but we don't have another 2 positions free here. So we, let's say, do some small trick. So we just make some round again. So we said, okay, 11, no. So we just count it in some different manner. So we skip to GFS 0 arguments because we need that 0 arguments, but there is only, let's say, 6 functions or 6 terminals. So we just make 6 and 5 again and get this variable. And now we've got the formula, and that's all. So the analytic programming is a really easy framework for you to use your favorite evolutionary or some intelligent technique, which will give you some let's say, integer vectors, and then you can map these integer vectors for the space of the terminals and the functions. So basically, this is here the bolded. So in other words, the analytic programming is only projection from the space of the integer individuals, which are given by some evolutionary process, to the space of possible programs. Of course, you have some problem which is being solved, so you need to fit the data, so you measure the distance between your new model and the data, and this is the cost function for example, the evolutionary process. So you know how far is your solution from what you basically expect from the process. And the most important thing, whether the analytical programming is more or less success, it depends mainly on the algorithm which is used and for the parameter setup. So you can use for example, very nice settings for arguments, functions, and so on. But if you use some like old-fashioned and not powerful algorithm, which is, for example, wrongly set, you also don't have nice results. So here is only some few examples fastly how to deal with the constants, because this is the biggest problem. Because if we add the constants to the general function set, basically you don't know which values are the best to add. And of course, if you add just one constant, then basically the cardinality of the problem, it's a factorial problem because it's a combination. You know, it's a combination or variations or permutations between the problems. So then the cardinality of the problem increases very much. So there are like three approaches. Basically, it's called analytic programming basic, where you only just put few constants, like a direct values like 2.0 or 3 into the general function set. Or you can use some so-called meta or nonlinear fitting process, which means that you are using some clever toolbox from MATLAB or Mathematica, which will fit the best values of this constant. Or what is interesting, you can use so-called meta evolution, which means that you are using the secondary evolution algorithm, which will find you the best values for the constants inside your program. So first evolutionary algorithm, the master one, will synthesize the formula, and secondary evolution algorithms will synthesize the best values for the constants. But the problem is that it's very demanding, because if you just say that, okay, I will let's say 10,000 iterations for the master algorithm, then you have to count that each single one iteration where every single solution is created, you have to run the secondary evolution algorithms, which has, for example, another 10,000 iterations. So it means that you easily get to 100 million iterations, which is very slow. So this meta evolution process is recommending only in case that you have some supergrid computer and you have a time to solve it. If you don't have a time, you have to use some clever and smart approaches like this nonlinear fitting, which can be done in MATLAB or Mathematica, or you can use some easy trick which calls extended individuals, and it's only can be seen very quickly here that you have to deal with the length of the individual. But for example, you will use only this part for formula synthesis, and this part you can use as a constant. So you can, for example, this one can be put it here. But the problem is that the evolution algorithms is creating two things together, the formula and also the constants. So maybe the let's say the evolution process where we are trying to find the best formula, and we are trying to find some extreme of the function, is influenced but only small tiny change of some constant. So, or the constant has a bigger, let's say, influence than the formulas. So this is a little bit tricky. Or you can use some direct approaches, which is here, direct coding, that there are two possible ways. That means that, for example, you use some unrounded part of the individual, divide it by the size or dimension of the problem, so there is some trace of the problem which is being solved and so on. So this is the concepts, and now just briefly some examples. We are also working with reinforcement learning. What does it mean? That, for example, if you synthesize some formula which is looking good, or it means that it seems that this formula is on the good way to solutions, why not to use this good formula as a, let's say, member of this general function set? It means that this formula will be somehow enhanced with another terminals and not terminals. So the reinforcement learning means that if you have some good solution so far in the middle of the process, you can put it into general function set, and it means that it will be selected and somehow enhanced again with some different combination of the parameters, which means some faster conversions towards the global extreme and the function solution. So just for the end, some applications. So we can use it. You can use it for data approximation, design of some logic circuits, optimal trajectory of the robot, identification of the system, some neural network synthesis, synthesis of some decision-making process, synthesis of some workflow, synthesis of, for example, we have used it for synthesis of some new systems for protection in cybersecurity, and there are many more. For example, this is the data approximation, so you can synthesize the mathematical formulas to fit some measured data. You can try to synthesize the, let's say, set of the commands for the autonomous robot to, for example, fly over some trail where is some food or traps, and for example, this benchmark is typical Santa Fe trail. So you can, this is the, for example, the final program which was synthesized with analytical programming. So you can see only just few lines, and there is some recursive process and so on. And with these commands, the robot can fastly fly or go through, for some trail with some obstacles and so on. And it's autonomous, so you don't have to control it. You just load you just load this, and you get the result. So this is, for example, another example of the commands which will solve this Santa Fe trail benchmark. There's a design of electronic circuits, so you can use some electronic components to design circuits. You can solve the Boolean problem. For example, we have used it for synthesis of some light control in some crossroad. And you can synthesize also neural networks, because you can use the components of the networks and then synthesize your own structure, or you can synthesize the pseudo-neural networks, which means that you not synthesize the components of the networks together, but you will synthesize the network as a big equation, because basically the neural network is nothing more than just a big equation from the parameters. So this is some visionary thing. You can synthesize the evolutionary algorithms by evolutionary algorithms. It's not a problem. We have done this. And basically here in the general conclusions, everything was already set. This is, for example, some link where you can download this package from the GitHub. So it's working, for example, in the Java. Now we have implementation in Mathematica, C++, C, generic C in CUDA for working in the graphical computing. And just for the end, did it work? You remember it? So you see the cowboy on the horse. So now you know that your brain is in good condition, and you know that this is how artificial intelligence works. So thank you for attention. Sorry for the a little bit quicker end, but we are a little bit behind the schedule. And if you have any questions, I think that we don't have a time for questions. Take it online. There's a contact for me. You can contact me by email, or you can write to the AI lab, where basically I'm the head of this lab. So basically, both contacts will reach me. And you are welcome to your ideas, suggestions, or if you need some help with some solving of the problem. It's not a problem. We can try to help you. We can send you some codes. We can send you some examples how we have done it, for example, in some similar examples. and you will see that, for example, it can help to solve your research problem. So thank you again.
Thank you, Roman. Thank you very much. Please give him a big round of applause. Thank you very much for the keynote address. We are grateful to you. Ladies and gentlemen, let us wait back for the next presentation. The next presentation would be given by Dr. Nabil from Springer. This is more general to the authors and students, researchers regarding the how to publish quality works in different proceedings, journals, including Springer. So may I request now Reshma ma'am to please introduce the next speaker.
Thank you, sir. It gives me immense pleasure of introducing today's speaker, Dr. Nabil Kelsey, Senior Editor, Earth Science and MENA Program, Springer, Germany. He holds a BSc in Natural Sciences and an MSc in Earth Environmental Sciences from the University of SPAX. He received fellowships from the Global Change System for Analysis, Research and Training in 2005 and the German Academic Exchange Service from 2006 to 2010 to continue with PhD studies in Marine Geosciences at the University of Kiel in Germany. After completing his PhD in 2010, Dr. Kelsey received a postdoctoral research grant from the German Science Foundation to pursue his self-designed research projects at the Geomar Ocean Research Center in the Kiel, Germany, which involved reconstructing past changes in oceanography and climate in the North Atlantic and Mediterranean Sea using marine sediment samples retrieved by the International Ocean Drilling Program and applying formalin and geochemical proxy methods. He subsequently published his research findings in prominent scientific journals. Dr. Kelsey also received funding from the European Science Foundation and some European universities to co-organize with colleagues from Kiel, Bordeaux and Bristol 2 workshops on plains climate in Bordeaux, France 2009 and Bristol, UK in 2013. In early 2014, he received the Swiss Government Excellence Scholarships to continue with his research projects in Switzerland. Although his interest in scientific research remained strong, in March 2014, he decided to pursue his career as senior publishing editor with Springer in Germany. He is mainly responsible for developing Springer's publishing program in the Middle East, North Africa. The program currently consisting of developing 18 academic journals from the Arabic world and publishing numerous scientific books each year. For publishing and career professional development workshops, most recently Dr. Kelsey was awarded the 2016 Africa Green Future Leadership Award in recognition of work contributing to sustainable development, advancing science and prominent publications in Africa and the Middle East. In 2017, Dr. Kelsey launched the first Springer conference dedicated to promoting the Euro-Mediterranean integration process, stressing the vulnerability and need for proactive remediation of the Euro-Mediterranean environment. Hopefully, we are having a very informative talk by Dr. Nabil Kelsey, so we are awaiting for your lecture. Thank you.
Thank you very much. Yeah, okay, thank you. So, thank you for staying to listen to my presentation. It is mainly addressed to early career scientists. It is about some techniques and hints, tips to how to prepare a good and successful paper with Springer. In general, any fields, I am not specifying especially your field of research, but it concerns, I shape it in a way that it concerns the majority of fields. I hope it will be useful, especially, as I say, to for early career scientists who would like to publish in impact factor journals, good journals in their field, which is very important for their career, I think. So just a few minutes and we will start. The presentation normally is 2 hours, but I will try to make it very short. So now there is no interaction with the mic. Okay. So what we shall do then? Okay. I hope it will stay the same. some details. The This presentation is to help how to shape a good paper for those who are interested in publishing in high quality journals. As you know, the goal is to just not only to be published but also to be widely read and cited in your field. And to reach that target, attracting good readership and high number of citations, it is important to know how to prepare and how to publish your paper. So there are three important criteria here, or skills to be to have them. So the first one is to write effectively. Effective way of writing is very important in science, and also the selection of the appropriate journal. Many good papers, they get rejected not because they are bad quality or something like that, but because it is simply not the appropriate journal. And an important criteria, which is the logical organization of ideas. The presentation will be mainly focusing on those three parts. We'll start by how to effectively write. I will explain later. So this is the plan. And as I said, I will try to make it short, so I will focus on the first important steps: effective writing, selecting the appropriate journal, and how to logically organize the structure of your paper. The first, effective writing. It is first and most important is you should always try to write simply, because if you write your thoughts in a simple way, they will be easily understood by the readers. You know this guy, of course. He said, if you cannot explain something simply, you didn't understand it well. So most of cases, writing in a complicated way, it reflects that you are not able to understand what you are doing and what is the target of your research. So try first to understand what is the aim of your research before starting writing your paper. Writing always to express, not to impress. And consider your audience. Sometimes they are not familiar with your research, of course, so you should simplify to them your thoughts. Following the KISS method, it is not about kissing here, but keep it simple and short. By keeping your thoughts and your sentences simple and short, this will help others to understand what you are doing. As I said, the target from the beginning is not just to get published, is to be read and cited. Citations, they play a big role in your promotion, in your career in general. So if you produce science and it is not cited, then it is not useful. One way to attract people to cite you and read your stuff is to follow the effective way of writing. The first recommendation is to write simple, express, not to impress. So the target is improving readability, and effective writing will help you to improve readability. People, they will read easily. By using short sentences, limit maximum 10-15 words per sentence and one idea per sentence. This is important. By using the active voice, it will show a more simple and direct and easier style of writing. And people, they can easily read it. Here I will show you an example of passive and active. Use it to express the same sentence. The first sentence is here an example. The models comparing the economic growth and diversification of the Middle East and Central Asia were evaluated. So you need to read the long sentence to understand what is happening. By using active voice, it is much more shorter and much more direct way. We evaluated, or they evaluated, they found, not were found or have been found. So this voice or this active style helps the readers to get the information much more quicker than reading passive voice. That is the first recommendation. The second is how to make a good structure of your sentence. I will show you an example here. Which sentence, the question is, which sentence suggests that you will get a rise? Okay, let's start. You deserve a rise, but the budget is tight. This is the first. The second is, the budget is tight, but you deserve a rise. So, it is confusing here. It is not easy to understand how to start, but I can tell you that the second structure is much more easy to get by the readers, because I will tell you why. Because readers, or the eye, it always focuses at the end of the sentence. So people, when they read, they don't have time. They always jump to the end of sentence to understand the meaning. So if you put the main information in the end of the sentence, this will help you to improve the readability. So as you can see here, the main message for the reader is getting the rise. And put it in the end of the sentence. We call this the stress position. At the end of the sentence, to determine what is important. And by inserting the most important message at the end of the sentence, this will also help you to link it to the next sentence. So, the budget is tight, you deserve a rise. The most important information is in the stress position. A rise in what? So to link to the next sentence, in your salary will increase when? The most important information, at the end of the sentence, at the beginning of the next year. So this is how to link ideas. We start by one thought, one sentence. You should make a brainstorming, what to put first, what to put second. Forget about what you did in your lab and experiments and so on. Now you are presenting your science to the worldwide community, and it is not an easy task. You are a scientific writer. You should not just put your findings and then self-service. Enjoy my big findings. No, people, they don't have time. They would like to read something easy, something attractive. And as early career scientists, those skills, they are very important to you, to your career. Otherwise, it will be very, very difficult for you. So, logical flow of ideas, that's what we mentioned here. Just I forget to say that at the beginning of the sentence, you put in the topic position the sentence or the most important information that you would like to draw a conclusion from that. Here it is the salary, and here it is the budget. So each sentence has one title. The title is that keyword at the beginning. So the first sentence should just speak about the budget. The second one, just about salary. No more ideas. One idea per sentence, okay? We agreed to be able to organize our logical flow of ideas, one idea per sentence, and we link each sentence to the next one by a topic link from stress position to topic position. So I think it is clear now. I will show you an example, and as you know, if you are able to shape, write, or in a good way, one sentence, link it to the next one, this means that you will be able to write one paragraph. A sentence is a group of paragraphs. It can produce a paragraph, as you know, and here the paragraph, I will read it quickly. This is the topic position. So the paragraph is about what? About dioxide titanium surface modification of the scaffold considerably improved its catalytic efficiency in the stress position. So the message is about catalytic efficiency, and you will link it to the next sentence. So the next sentence should tell us about the catalytic efficiency. So the increased efficiency was prominent early in the reaction, but stress position, the main message, decreased over time. So the third sentence is about time. The lack of long-term effects, it is time. You should not always use the same words. The lack of long-term effects, because we say decrease, lack of long-term effects of dioxide surface modification was likely due to the reaction being conducted, stress position, most important information in an aqueous environment. Okay, aqueous environment is chemical solution. So, evaluating additional solvents to improve what? We return here. The catalytic efficiency over time is currently being investigated. So, here we have used the passive because it is needed, but in general, all sentences, they are in active voice. And the first position, topic position, should introduce the content of the full paragraph. So this paragraph has a topic position, dioxide surface modification, and the stress position is currently being investigated. I will show you why, by following this style of writing, the readability of your papers will be much more better. Let's continue. As I said, there is a link between topic and stress position. Here, I will show you the example. I will not read all of this, but this is not just the topic word, but the topic sentence of the whole paragraph. And here it is the support. And of course, at the end, this is the stress sentence. So even when we select sentences in the paragraph, we should put the topic sentence at the beginning, and then supporting information and the stress sentence. Why? This to help readers to read quickly. Sometimes readers, they are not interested in this part. So you just give them a title of that part. And if they are interested, they will continue reading the support information. If they are not interested, they will just jump directly to read the stress sentence and continue. Don't forget, the aim is improving readability. Let's try. Lung cancer is the leading cause of cancer mortality for men and women. I am not interested to read that. So, directly, new ways to treat or prevent lung cancer are therefore needed. So, you understand without reading that those few lines, they are just about this topic that you are not interested to continue reading that. So if you are organized, the reader will not lose any information. And if they will return to read again, they will know where to find it. Just by looking to the first sentences of each paragraph, you are extremely organized. You put your major thoughts in paragraphs, and for each thought, you make a title and a conclusion to link to the next paragraph, which should speak, if you are organized writer, which should speak of at least one way. As you can see here, one potential therapeutic target for lung cancer is this signaling pathway. So the next paragraph will describe that pathway. If you are interested, you can read it. If not, you can jump to the next paragraph, and in that way, you will quickly scan all the paper and select what is the most important science, link it to your own research. So this will gain time. It will reflect that the authors, they know how to present their science. Okay, this is what means effective writing, so it is not difficult, yeah? That is effective writing, so it is effective communicating your science. Now, the most important step, which is also very important, is how to select your journal. Selecting your journal is also, it plays a big part in that. Choosing your journal, I will go quickly because the third part is much more important. You read the author guidelines, manuscript structure, the word limits, all of those factors, they influence the first assessment. And you should compare whether the aims and scope of that journal, you will contribute to the scope of the journal. You will add a value to that journal. If your paper will not add, don't submit because they will reject it. Have a look on the topics and readership, and always use relevant references, writing style, as we discussed a few minutes ago, always after evaluating the novelty and relevance of your findings. Because some journals, if there is no clear novelty, some journals, they ask for a novelty statement. If there is no novelty, don't lose your time. It can stay with them for a few months and then they will reject it. And you don't have time, of course. So evaluate yourself before you submit. So we have a tool in Springer to help you, and I think other publishers, Elsevier and others, they have that tool. But here I will just speak about Springer. I'm representing Springer. You just Google Springer Journal Selector and insert your paper here or summary, and you can click here only journals with the impact factor or journals that they provide open access. And then you can find your target journal. Here they are the most related journals to your research, for example. And Springer recommends that you go to those journals. It is a small software that calculates your keywords and so on, and if they are linked to the scope of that journal. You can filter the impact factor if you don't go really to high and tough journals, the publishing frequency, how many issues, and if it is open access or not. And if you select your journal, for example here, Space Science Reviews, you go and read about the aims and scope, see all details related to the journal, and decide. Also, this tool, it is good because it gives you free access to similar articles from this journal. So you will get access to the papers that they were published in the journal, but they are really similar to what you are attempting to submit. So it's good to cite those papers to show that you are aware of them, and also to evaluate whether your paper is on the same quality or better.
Innovative operations in the knowledge economy. He is consultant on innovation and strategies for startups and SMEs and contributed to make many startups successful. He holds a PhD from IIT Kharagpur to many management education from IIM Kolkata. UCSM Monarch Business School, management at Switzerland, conferred higher doctorate on him for his contribution towards innovation and knowledge management. Recipient of Oriental Foundation Scholarship, he is also a fellow of IATE and the IAP. Dr. Parag is founder, Chief Scientist, CEO of the Innovation Research Labs Private Limited, an innovation strategy and business consulting and product development organization. He has been a visiting professor at technical and B schools of repute including IIM, Nazareth University and COEP, Pune. Dr. Parag has headed various organizations and research labs and contributed to success of more than 1 dozen organizations through his strategic and business acumen and innovative product building. His core contributed to more than 12 commercially successful products. He headed research labs at Siemens, Ideas, and many other organizations. One of the well-known product innovation and business innovation strategists. He is advisor to many industries and academic institutes. His work includes innovation and knowledge strategies for startups, knowledge strategies for organizations, building innovative products, breaking away from competitive landscape. His work is on systemic innovation and learning is published with many reputed journals. His work on systemic machine learning is published in the form of a book published by IEEE. We call it Reinforcement and Systemic Machine Learning for Decision Making. He co-authored many more than half a dozen strategy and innovation books including IT strategy, e-business and deliverance from success. Dr. Parag has published numerous articles, more than 300 plus research papers. He delivered numerous talks on strategy and management startups, knowledge innovation and building systemically intelligent products and conducted 200 plus management programs on deliverance from success and knowledge management. Dr. Parag is also a great orator and has delivered more than 1 million students and professionals benefited from his talks and guidance. He is also known for his humble efforts to transform so-called academic underachievers into passionate and happy warriors. He did extensive research in machine learning and intelligent systems and contributed to many AI-based products. Thank you so much.
Take a different perspective on machine learning, and it will be more like a discussion. And thanks for Siddhartha. Swagatam, sorry. Thanks to Swagatam for wonderful talk. And he's a great researcher. Right? I think my age is catching up. Okay. So dear friends, I have slightly different topic. Uncertainty going beyond the saga of machine learning. So in this talk, I will try to take a different perspective on machine learning. What can be machine learning? What could be machine learning? And what machine learning is not? And where it can progress. And actually, initial work regarding this thought process, I presented at ANIT almost 2 years back. And that time, Professor Lakshmi Jain was there, and he listened to talk and invited me to write a book on that. And the book is published by Springer, Reverse Hypothesis Machine Learning. And the book is available. So I will be very brief, and I will try to complete in next half an hour or 40 minutes. Because I remember one interesting episode. One fine day I was giving a talk, and one student raised his hand and asked me, what is Newton's fifth law? I got confused. I am not that much learned. I know second law, I know third law. I don't know fifth law. So he said fifth law is very simple. Whatever may be the length of the talk, knowledge at the beginning of the talk and end of the talk remains constant. So dear friends, I will try to be as brief as possible. This is just vision of annihilation. We are trying to unleashing innovation and democratization of machine learning to empower all stakeholders across the healthcare and agro-value chain. And the idea is not a single person should be deprived of right and timely medical advice. And with that vision, Annihilation is working from last 3 years. Just keep this. These are different areas we try to work as Annihilation. Knowledge innovation strategy, deep learning, deep reinforcement machine learning, and there are a lot of variants are coming up. And then you can add a few more, because there is a lot of scope to that area. These are the books written by me. Most of them are available with on Amazon as well as And YD that we just talked about in the morning, which is fourth in the bottom row. Machines are not ready to learn. They are mugging up patterns. They are becoming like a student. They are not ready to think. They are just mugging up, producing marks. And whether you take a deep learning or Google, whatever it may be, they are just trying to produce whatever given to them. So they are mugging up. They are producing and repeating what the other machines are doing. They are simply not learning. So that is my complaint. The machines are not ready to learn. In spite of so much machine learning research, they are not learning. Basically, it is an input-output. You are giving a lot of outputs, they can memorize it and produce it. Is it intelligent learning? Because learning definition evolved right from 1940. When people talk that, okay, even mugging up is a learning. You just reproduce, it is a learning. Today we are not ready to accept that. Just reproduce probably is not learning. So probably pattern matching is a different form of reproduction. Because you learn the pattern, you reproduce the pattern. You map the pattern. So if I learn 1,000 patterns, it can map 1,000 patterns. If it can learn 1 lakh patterns, it can map 1 lakh patterns. If it is 1 million, okay, you require more energy, you will require more power, you will require more processing, you will require GPUs, you will have an array of processors, whatever it may be. But again, at the end of the day, we are mapping. So can every machine have a different message? Can it learn from the context? And can they learn cooperatively? एक machine ने पढ़ लिया, दूसरा machine is learning from that, as human is doing. So that is the thought process. Before that, I will try to give you one very interesting story. I like to give that story, and also I have included in the book that reverse hypothesis in learning. And this story is of an actor. So to explain what machine learning is, those are already in previous talk, they already talked about machine learning, so you know what machine learning is. But I will try to tell in my own style. This is a story of an actor. There was one very versatile actor, very well-known actor. There is a very strong theatre industry in Bengal also, very strong theatre industry in Maharashtra, in Gujarat is good strong. I know there must be in Andhra also, I am not familiar with it. So his plays were very popular, and for plays there are shows after shows. Same play they perform every evening, or maybe alternate days and so on. Like there is one very popular play in Marathi, there are almost 1,000, more than 2,000, 3,000 shows of the same play. So this guy's play was very popular. One fine day, this guy was playing a lead role in the play. And there was a climax. Climax, as we know, all of you know that climax means way to the emotions. If you take an Oxford dictionary. So in that typical shot, what was the scene? That this person who was supposed to be in positive character is supposed to pull the revolver out of his pocket, direct in the direction of the person who is in negative character, tell that you are such a bad guy, you did this, you did that, and I am going to kill you, and fire at that person. But there was a twist in the tale, because this is a story of 1940, probably when machine learning is yet to come. Okay. So there was no sound system. So what they used to do, when this person pulls the revolver out of his pocket, directs and explains that I am going to kill you, the two persons at the back of the stage are supposed to burst the balloon to make the sound of fire. Okay? So this guy pulled the revolver out of his pocket, directed in the direction of the person who is in negative character, and said, "You are such a bad guy, I am going to kill you." Unfortunately, there was some problem at the back of the stage, and balloon did not burst. This guy got worried. But he very intelligent actor, thought that probably the person at the back of the stage must not have heard that what he said. So he again shouted, "I am going to kill you." Unfortunately, the balloon did not burst. Now he got worried. But again, he was certain. So he he looked towards the person in negative character and said, "Itni आसानी से मरने नहीं दूंगा. I will not allow you to die so easily. Let me tell you the whole story." So he said, 10 years back you did that to me, 20 years back you did that to my father, 30 years back you did that, this, so continue. And after ऑडियंस भी परेशान हो गया. ऑडियंस से अरे मार यार मार, this that as you were, so you deserve that, and I'm going to kill you. He pulled and he directed the revolver. Unfortunately, balloon did not burst. अभी बंदा और परेशान हो गया. But again, versatile है, very intelligent actor. I think you are lucky. There is some problem with this revolver. But don't worry, I have this knife. He pulled pen out of his pocket, some silver pen. Probably 1940 light arrangement, you could not make out whether this is a pen or knife. He pulled pen out of his pocket. He ran to that person. He was about to stab and balloon burst. So no nothing. People thought here the shot we should invite class, people invited loss. So that is typical reinforcement learning. Instead of you are accumulating rewards, and maximization of the rewards is the function of reinforcement learning. So instead of rewards, he is now getting penalties because people are happy. So he thought about that. And this is typical supervised learning. Now days went like that. One fine day again, same shot. He said, "You, I am going to kill you." Again same problem, balloon did not burst. He used his old trick, he shouted, still balloon did not burst. Then he used again his old trick, saying, "I will not allow you to die so easily, let me tell you the whole story." He told the whole story. Again shouted, still balloon did not burst. Then he said, "Okay, there is some problem with this revolver. I have this knife." He put pen out of his pocket. He ran to that person and he was about to stab, and unfortunately this time also balloon burst. But he looked in different direction and said, "Oh Robert, you killed him. I knew you wanted to kill him." That is learning. So what is it? It is evolution. Every time you are getting more information, you are accumulating your, and probably that's why reinforcement learning comes very close to the learning paradigm. If you look at learning, reinforcement learning, I am a fan of reinforcement learning because I think it's very close to the way learning behavior is expected, but not 100%. And we'll also touch that aspect. So this is actually a simple paragraph I have taken from internet. Right? And then I use different available softwares on this paragraph. Okay, what to conclude from this? And then simple TF-IDF measure said that there is a frequency of bump word maximum in it. It's occurring 4 times. So I go for talks at different places. Even I was taking this innovation course at IIT Bombay last year. Even I took workshop on innovation at IIT Bombay a couple of times because there is an innovation elective. Even I was mentor for this SCI initiative by IIT Bombay. So they also had one workshop. I gave this similar paragraph and asked around 200 students, which word you think is important? And interestingly, around 70 to 80% students said that stop word is most important word. And no software considers stop is the most important word. I don't know what is the reason. Maybe if you go over by frequency, bump is the most important word. So I asked the students, why do you think stop is the most important? So they mentioned that the purpose of this paragraph is stop that bumping. So there is 2 important words. Stop is the most important word and bumping is probably the next word. This bumping to be stopped, and that is what this paragraph is written. Now, if you approach this problem differently, maybe some mathematics, there is some mathematics, we have a couple of algorithms on that. And if you do association, some sort of disambiguation and all that, and you try to associate different words, calculate the importance, probably you can come to that conclusion. I'm not saying it is very difficult, but it's possible. What it is indicative of? It is indicative of probably this context of this particular thing is not identified by the machine. It's not a very complex thing, but that context is not identified. Because it is generally about the context. You did not write the answer correctly. If it is a test examination, reaction is different. If it is just some nominal test examination, again different. If it is actually a state board examination, it may be different. If it is JEE, final mains or advanced mains, probably the reaction is different. It depends on context. Finally, everything depends on context. Now, I have another example. That is, I don't know, 1 year back slide. So maybe Google has improved by it and has कुछ भी वन बस का मतलब this is one of the very well known Hindi poems. कुछ भी वन बस का मतलब ठोकर मार पटक मत माथा तेरी राह रोते पहन कुछ भी वन बस का मतलब तेरी रक्षा का अनुभव है. Very wonderful poem. I like this. I tried to translate it with Google Translate. This is actual screenshot. I haven't played with it. So the translated some also becomes just overly word. If plan the word carved out, your way to prevent pahana, some also becomes just overly word. No meaning at all. It could not translate. I don't want to blame Google. Probably with a lot of you say cooperative learning or maybe crowdsourcing, they will do it in a better way very soon. Or probably today in a way. The question is whether this is the learning paradigm is correct. I am not questioning that they will be able to do it, they will not able to do it, forget it. We are no way can say that Google is not doing correct as long as we do something, right? But questioning, can there be a better paradigm to approach this problem? Or are we trying to approach all the problems in the same way? So, in this quest, I will just try to give you definition of learning by Peter Senge. Learning does not mean acquiring more information, but expanding the ability to produce the result we truly want out of the lecture. So very good definition. It's from book Fifth Discipline. A must-read book, a wonderful book. It talks about systemic thinking, and I inspired from that book systemic thinking, and I wrote the book Systemic Machine Learning, which is published by everybody also, which was So you can define machine learning in the same way. Machine learning does not mean acquiring more information by the machine, but expanding the ability of the machine to produce the result we truly want from it. Fine. And then finding more through available knowledge, through association, meta-reasoning, exploration, expansion, transformation, and mapping. There is one very good book written by MIT Press, meta-reasoning. Meta-thinking. What generally is happening in typical machine learning, whichever you take, I am not talking about SVM or expectation maximization or maybe you can take Bayesian, whatever you take. The idea is that this meta-thinking layer is absent. Meta-thinking layer is absent. That's why it approaches this learning problem in completely different way. What is meta thinking? What is metadata? You know, right? Data about data is called metadata. So thinking about thinking. Reasoning about reasoning. So this layer is our human being has this layer very strong layer. We think about reasons. ये हो गया तो क्या होता है, ये हो गया तो क्या होता है. Maybe sometimes it may be wrong, sometimes it may be correct. I am not talking about accuracy, I am talking about the capability of meta-reasoning. And interestingly, human being is gifted with a tremendous ability of meta-thinking. It can be meta-thinking, it can be meta-thinking. You can always relate. Even I start कि आज का फ्लाइट डिले होगा तो कल का डिले होगा तो क्या होगा, फिर मैं हैदराबाद पहुंचूंगा तो क्या होगा, फिर हैदराबाद के बाद में का फ्लाइट का क्या होगा, फिर घर में पहुंचूंगा तो क्या होगा, what will happen, then what my wife will do, whether I will like it that, or I will have acidity problem because I will reach a and I start a lot of things. In positive as well as negative relation, even I will try to find out reasons of ये हुआ क्यों हुआ, ये हुआ क्यों हुआ. So I'll give you another very interesting insight. There is a book written by Harari. He's a scientist from Israel. It's a wonderful book, Sapiens. And I think it was one of the bestsellers and many copies are sold. What he tries to say in the book, that we did not evolve from Neanderthals. There were two similar species like us in the past. One is Homo sapiens and one is Neanderthal. Homo sapiens were thin, short-heighted, short stature, maybe about 5 feet, 6. In the exceptional cases, 5.5 or sometimes 6. They were not that strong. And Neanderthals were huge, around 6 feet, 6.5, 7, sometimes even 7.5. They were very strong muscles. And they had ability. If they put in front of Homo sapiens, they could have very easily defeated Homo sapiens. But interestingly, we did not evolve from Homo sapiens, or Neanderthals, but we evolved from Homo sapiens. And Neanderthal became extinct. Right? Why Neanderthal became extinct? Harari takes crack at this, and I think that can be the future direction of machine learning. Because I am machine learning researcher and I don't read machine learning books, I read other books and try to find out machine learning. Maybe that may not be a good idea, but I am trying to do that. And I have almost 1500 books in my library and almost 100 plus psychology books. So I like to read, or at least I like to collect the books. Reading is a difficult task, right? So what is the reason why Homo sapiens survived and not Neanderthal? So he tries to analyze that, and he had found out number of reasons. And very logical reasons, I will try to tell you. One important reason is, because Neanderthals were huge, lot of energy Neanderthals had is gone into feeding their other body parts. Energy is day-to-day activities, and very less energy is going to brain as an extra energy which can grow their brain. That is one reason. But there are very interesting other reasons that Homo sapiens survived because they had ability to learn from uncertainty, ability to learn from boundary conditions, ability to learn from exceptions. They were not 100% learning from patterns. Second thing is intolerance. So probably they were not tolerating models, maybe they were trying to overcome it. Third thing is building non-existing myths. For example, company is a non-existing myth. Right? Tata Group is still there, Zorabi Tata is gone, JRD Tata is not there, still Tata Group is there. Money is another myth. Right? Bola to, it's a myth. God is a myth. Who has seen it? No one has seen it. Myth. Even colleges, companies, trust, examination, everything is myth. And we have created a lot of such imaginary entities, and we assume that as a truth, and we work on that. And that is a very interesting ability, right? That contributed to our learning. And that's why we have ability to learn differently. And then imaginary entities. These are actually books. Now, there is another book, Black Swan. Black Swan also talks about uncertainty. Another bestseller. What he tries to tell you, the activity or the actions or the incidents, those did not happen in our life. have more impact on our life than the incidents those actually happen. And pattern-based learning basically works on what happened in our life. What black swan is, the basic theory of black swan is that the events those did not take place in our life have more impact on our life than the event those actually took place. Then again it's an imagination कि ये हुआ होता. Even I'm inspired by this Black Swan book, and in our company we don't invite resume because resume are pattern-based. Everyone writes Java, C++, this, that. They don't know anything, still they write it. They write he graduate from this, and that is your bias. I said PhD from IIT, then someone will get biased, and even though I am not eligible, someone may recruit me, or whatever it may happen. So it creates bias. So there is a concept we develop which is called an anti-resume. You don't write a resume, you write anti-resume. Now what is anti-resume? You suppose there is a particular JD, job description, and suppose I have this thing for job description. I will invite that person to write only what is they think is required for that job description and what from that they don't know. And in 3-4 lines. And what we did, we conducted interviews of 25 candidates from different colleges, very good colleges from Pune, for 2 posts in our company with anti-resume. We did not ask them whether they are, which college they went to, what qualification they have, what publication they have. We don't want it. What citation? Nothing. We want only, see, this is a job description. What do you think that job description expects from you? And out of that, what you don't know. If they write their qualification, we just rejected them upfront. So we had 25 applications. We did not know the qualification of them. We did not know even whether he is a BSc, BCom, MBA, electrical, civil. We did not know. We knew only. And then out of these 25, we invited based on 15 candidates. 15 we interviewed and we selected 2. Again, during interview also they were not supposed to tell from which college, from this thing. And we selected 2 candidates. One of them is Samir, who is working in our company, and another is Sachin. Samir has 41% marks from one college from our company. And he is one of the best coding resource of analysts. So what this proves, I don't know, but we found it is working for our company. And our company is very intensive because it's a small startup. You have to work on different activities. You have to be very active. So what does it suggest? I don't know. Maybe you can conclude because we haven't conducted many experiments like this. But this is inspired from Black Swan. So let's go of certainty. The opposite is not uncertainty. It is openness, curiosity, and a willingness to embrace paradox rather than choose upsides. Embrace relational uncertainty, it is called romance. Embrace spiritual uncertainty, it is called mystery. Embrace occupational uncertainty, it is called destiny. Embrace emotional uncertainty, it is called joy. Embrace intellectual uncertainty, it is called revelation. And we think that next step of learning is revelation. If there is no revelation after learning, probably learning is not happening. And with that thing, so now how to make machine learn like this? Question is, okay, this is fine. The theory, I don't know whether you are satisfied, but I am satisfied with this theory. Okay? And you can always question that theory. So, how to make machines to learn from this, and can we make it happen? So then a lot of thoughts came into my mind. I was actually first PhD guide in Pune University in computer engineering, XU, government college, because they didn't have any PhD guide that time in 2000, before 2000. I did my PhD almost 20 years back. So that time they didn't have any PhD guide, so they invited me to guide, and I started guiding. I was externally associated with the college, and so I got a lot of help from very bright students who worked with me, and we worked on a lot of imaginary things like this. So, and some of them really did exceptional work. Now, so how to make, I will not talk about this because this is one very nice book, Teaching Thinking by Edward Digger. He says that thinking can be taught. So the idea was that can we teach the thinking, then again learning, these concepts are related. I'll just skip quickly. I just tried that everything should be imaged. We tried to make presentation in different way. Just photographs and not words. Minimum words, maximum images. But just keep it. I think Apple could not cope up with this. Or Microsoft, I don't know. Creative mind. This lady, Margaret Boda, has also, she did put a lot of interesting thoughts on AI and machine learning related to psychology. And she has written almost 3-4 books, and all of them are very good. So there she tries to put 2 types of creativity. One she mentions is historical creativity, and another she calls it psychological creativity. So what is historical creativity? Historical creativity means you are trying to produce something no one did in the past. And psychological creativity means you are trying to do something that you did not do in the past. Historical means no one did in the past. No one did in the past. And psychological means you haven't done in the past. Someone might have done it. So that is called as psychological creativity. So the idea is, can machine have a psychological creativity? That without getting input, it is trying to do something with some minor inputs or uncertainties which it has not performed in the past. So we tried to put the mathematics around. And we thought that, for example, suppose there are outliers. Generally what you do about outliers in the pattern, you just omit it. You don't take outliers. So instead of removing outliers, just take outliers for the learning. That is one experiment we conducted. There was some little bit of success, but it didn't work to the extent because the outliers has a lot of issues. Now, another thought came, can we take the only boundary conditions for the learning along with patterns? Because what happens is that you can't escape patterns. Finally, human beings learn on top of patterns. You are not just ignoring patterns. Patterns are there. Apart from that, you are doing something. And when you say someone is creative, when he comes with a surprise, then something is more obvious. Correct? When you say someone is intelligent, that he is not behaving, not producing the expected behavior. It is unexpected. So we did some sort of psychological mapping. So for what we did and just talk about some experiments, and that book is already there in the market, that Springer book, and maybe the work that we carried out in last 1 year we put in another form, that is say maybe reverse hypothesis, and we named it as a reverse hypothesis machine learning. Because there are two paradigms we thought. If whenever we are learning that we are mapping the cost to the result, we say it's a forward hypothesis machine learning. How the hypothesis driven development works? You write the hypothesis in a particular way. What is hypothesis? Hypothesis is some statistical presumption. Not just some sort of assumption which you think true because statistics are supported. For example, if I talk more than 1 hour, people will get bored. Maybe it's a hypothesis. But suppose maybe it will be true after, maybe I will keep talking and after some 15 minutes someone sleeps, then it will be true. So same way. And we have some measure in the hypothesis given your statement. Hypothesis is proven if 90% of the students sleep, or 20% of the students sleep after 1. Now this is typically called as forward hypothesis. Now that's why we gave the name of the reverse hypothesis. Again, I like that name, that's another reason. That's why we called it as a reverse hypothesis machine learning. Previously it's a knowledge innovation and machine learning unit title. And then Dr. Jain also like this name, reverse hypothesis machine learning, and we discussed that. So the idea is that, for example, we learn from boundary condition what will happen. So we try to collect the boundary condition on top of patterns. Now in support vector machine, what typically happens that you have these two hyperplanes. These hyperplanes you use to separate two classes. Because typically people say that any machine learning task can be identified as a classification task. May not be true, but typically. Like you say, previously in AI book they used to write that any AI problem can be a model or a search problem. And we used to learn from that breadth first search and depth first search, and we used to learn. So that same way, we thought that instead of these parallel vectors, can we have orthogonal vectors? And from this exception or boundary condition data point, we try to go for this orthogonal vectors. And we have produced results. What interesting outcome is that we found that there are certain applications in which it gives better results. Again, it is not proved 100%, otherwise I would have got some better awards or something. It's not proven 100%. I got just publications in that books and others. So but interestingly, one single reviewer has mentioned that probably that will be the next wave in machine learning. That's a very good positive comment we got when we submitted reverse hypothesis machine learning. One of the reviewers has very nicely mentioned that probably this will be the next wave. So we are hopeful that our thought process has some direction and people are appreciating. Now, what is the idea? This creative machine learning, you can call it. Creative machine learning means machine will learn about the next action without any preceding pattern, based on some boundary condition. Because you can't, without any data point, it will not learn. Even human being also learns without any data point. Probably there must be some data points in the brain which is already there, but you don't. Correct? You say that it's born intelligent, so that there must be some data already stored or something that evolves. So we targeted this boundary condition as the exception, because this boundary condition, and then around that boundary condition we tried to build a cluster slowly with these orthogonal vectors, and we tried to apply in some creative way. So when we studied this, we found that there is one long back, there was one MIT long back, not long back, maybe 10 years back, MIT lab had one experiment and they developed one auto fiction writer. The machine will write fiction. and that project was published as a book. The book is also available. If you MIT Press research, that book is available. So they have some initial thinking what I thought in alignment with what we are doing. So we again that is some sort of support to our thought process. So now at the next level, what we are trying to do, whatever they have used and whatever we have used, can we draw something, some concluding thing, to learn from that, to build. So these are actually imitation, variation, combination, transformation, and then there is the creative space, which is in the boundary area, and we are targeting that space. And then we have some sort of outcome of the result, and for that we use another technique which is called as intent action. What happens that whenever we were basically dealing with unstructured data, and when we look at any unstructured data, there is a sort of intent. There is a sort of intent, and that intent is mapped to the action. And when there is an unexpected action, so for that we collected some 5,000 student data, and in the form of stories. So what we try to do that resulting new relevant combinations, which may not sound relevant at the moment of the discovery. Then something new, not obvious, and may not be directly derivable, and unexpected map to expected. So that type we divided. Even we divided the thought process coming out of the outcome of the text into three forms. One is creative, one is normal, and one is random. And then random, actually creative is the sub part of the random. That will be tried to derive it. We are trying presently, because these are the areas in which we are working. Insurance, that is like a healthcare insurance. Healthcare, dynamic application, and some gaming. So couple of our customers want that reverse hypothesis machine learning to be embedded into the healthcare product which we have given them. Because we showed them some data on which we found that some sort of diagnostic results are coming very good. Because some unexpected things are tapped, which are not typically patterned. But anyway, we have two ways. These are some case studies where we work, and some good clients. We are consultant to a couple of Fortune 500 companies, then even a couple of very good companies in India, Tech Mahindra, SAPNET, Delmont Solutions. And we are doing a lot of experiments with our clients. So as said by Rutherford Roger, we are drowning in information and starving for knowledge. So trying to derive some knowledge. We do agree that we are at some initial stage. I will read this poem and I will conclude. Everyone is running after the goal with all stress and strength. Everyone is forcing team as a whole in the storm and the rain. Sometimes I wonder and ask myself, do I know the real goal? While running fast all along, have I forgotten my true goal? It goes like that. It is the rat race. Body gets tired, slow. Success needed without. Deadlines are made sometimes. Those are missed many times. We try to laugh before we are happy. We try to balance on the surface of. Today when I am looking back, there are just pieces of thoughts. Less success and more loss. No light and everything is dark. Let me tell you the only fact. Light is inside and outside is dark. Look inside for the light and light. Then you can enlighten the world. So this is. You can reach out to us at contact@Evolution or parag@Evolution.com. And if someone is really interested to do something different, may not, I don't know how much value you can pay to them, but definitely a lot of people enjoy working with us. Thank you. Yeah.
Regarding the presentation lab, so you mentioned that why to use orthogonal basis? Why to use parallel support vector machine in place of actually in the evolution earlier orthogonal basis were used.
Okay.
Then people moved to this parallel basis.
Correct, because but that time what was the result probably? The idea was that you wanted to address the complete data set and get good classification. That was the objective. Now what we are thinking, that is already achieved. Now we are building on top of that. So we are trying to get outcome on top of that based on it.
I find it orthogonal, parallel, both of them were.
Yeah, it will be there. We are not touching the existing thing because that is already great. Right? Machine learning, great work is done. We are only thinking that can any other paradigm can overcome the limitations posed by existing scenarios. Even we try to derive a concept which is called a context vector machine, and that also has, because instead of what these vectors, these are not context vectors, these are feature vectors. If you look at SVM vectors, these are typically feature vectors. Can we build a context vector? So idea is that first define the context, and then context vectors are different than feature vectors. So that was the thought process.
If that is the case, obviously my programming model becomes a detrimental factor for implementation of all those ideas. Then how do you overcome that?
That definitely is a challenge, because what we suppose we have creative machine learning, like let's say you have deep machine learning, then you need deep architecture, and a lot of things change. So tomorrow, let's say like even in MIT that book also, he said that probably they need a different language and different way of handling more things if they want machine to write let's say fiction. If we use the present system as it is, probably machine will not be able to do. The same way, if we are thinking of creative machine learning or reverse hypothesis machine learning, probably we need to put it in a complete creative machine. But anyway, there are a lot of challenges. Some initial results are very good. That's why we have converted it in book.
Which language for implementation?
We have using Python. So most of Python plus Node.js is a combination. We are doing most of the things right now for this research. But definitely I think we have to go to a next level where we are probably made it to organize the complete data in a different way.
Is there any possibility to have a soft compiler? A compiler which do not look for a grammar. It is not driven by a grammar.
Possible.
Once I say grammar, it is structured.
Yeah.
I don't want any structure to be imposed.
Yeah, good idea. Maybe something definitely that may evolve to that. Yeah, wonderful.
There was recently, I know recently that the chase game Alpha OCO, and that robot didn't have any previous history of the chase game, but still it could beat the other computers and there. And it was said that it learned on its own. And
this is typically reinforcement. All gaming is based on reinforcement learning. And I already mentioned that reinforcement learning comes close to this. What reinforcement learning does? That right now I don't know the scenario. I will take action, right? And then I will look at your reaction, and based on that I will collect the rewards and penalties. For example, if you are quick to collect the rewards and penalties, you are quick to correct your mistake. So in a way you are learning, because suppose I made a particular move and it died, my pawn died because of that move. What does it mention? It tells me that move was wrong. For example, cricket, let's say someone is batting, let's say there is a short field delay, and or maybe let's say there is a spinner, and I come on front foot and I try to hit that, and I'm beaten. So next ball I will try to put on the back foot. So that is the reinforcement level, typically. You are doing reinforcement because you got a penalty. We have even one interesting patent we have. We have developed, and that is a prototype in our office also, that is in making, and we have filed a US patent as well as Indian patent. That we, because what happens, like, for example, I am talking here. I don't know how many people are interested. Maybe someone is talking, someone is playing with his mobile, but I can't make out from their faces. So what we thought, there will be a sensor attached to every chair. Those sensors will capture number of things like pulse rate, body temperature, perspiration and all that. There is a complete matrix. And based on that, we calculate the boredom index. So how much everyone is got bored. And then we will have an accumulator, and in front of the speaker that boredom index, cumulative boredom index will be displayed. And speaker should make sure that it should not hit the threshold, otherwise it should stop. So he should crack the joke or do something. So, and interestingly, we have built a prototype. Accuracy is not that great, but anyway, I think at some point of time it will be. It's a combination of IoT plus behavioral, but reinforcement also.
It depends on where do you start and what moves are taken. I mean, is it luck-based or random?
It won't be from scratch. If you give the example, it has to be. First thing is chess rule must be already failed.
Yes.
Then second thing is it must have already few things, and then it learns. Because for basketball also there are trainers built based on reinforcement. So they try to identify whether the player is novice or a seasoned player, and based on that, that trainer gives them. And they try to build a robot based on reinforcement learning for boxing training. So if there is no novice, it should not hit hard to that level. So that type of, many people have taken reinforcement learning for this. And it's a wonderful approach. There is the idea of deep reinforcement learning. That you remember everything plus you have reinforcement. So that's another good combination to solve these problems. So, okay. Thanks a lot. Thank you.
Thank you very much, sir, for your thought-provoking lecture. It's a very nice conclusion of today's session. So all the participants are requested to join dinner at Minerva. If you are all anyone interested to join over there, the bus will be available at 6 o'clock in our college campus. You can join them. Thank you.